I just want to talk a little bit about Skydio and my career, my pathway getting here, and hopefully give you a sense of not only working in robotics, but what it feels like to try to work as an engineer in a field that changes really fast for a long period of time, because as you'll see, it's been a lot of different things. So I'm going to start by talking about Skydio. Skydio is the leading American drone manufacturer. There is another manufacturer of drones in a different country. You might have heard of DJI. That's of course the big gorilla. But I think we really can say that we're the world leader in autonomous flight, and that's how we got our foot in the door against such a big competitor. We got our start with drones that would autonomously follow you while you're doing things like mountain biking or sports photography or snowboarding, kind of like a GoPro that flies automatically, and then some cinematography things. And then over time, our mission grew. Right now, our mission is to make the world a more productive, creative, and safe with autonomous flight. I think the big insight was that if we had a drone that could put a camera anywhere in 3D space automatically, it can be quite useful across a range of industries. I'll talk about some of these use cases, but these are being used by public safety, for inspections of bridges and critical infrastructure, power substations, inventory management, roof inspections, all kinds of things. So here is a slide that our CEO, Adam Bry, likes to give. Sort of the arc of autonomy, and I can sort of say where we're at right now. Stage one is being on site with a vehicle and being able to have it automatically do something useful for you. So maybe, like I said, you could use your controller and set up a couple of waypoints and have it kind of go back and forth like a cable cam and make a cool video. Stage two was to have more complicated autonomous workflows, like our 3D scan skill that I'll talk about, where you can guide it to automatically capture a 3D volume and capture every facet of a 3D structure so you can do a 3D reconstruction of it. Stage three is to not need to be on site to do this. I'm going to give a demo later of operating a drone remotely, and you can essentially teleoperate the drone and plan something that can then be run automatically remotely. And then eventually you want to level up and maybe have one person be able to orchestrate multiple drones. I would say we're somewhere between 3 and 4 right now, because you can have a fleet of drones at a site and then schedule a bunch of missions that you want to run automatically, and they'll just run on a schedule. So you already have kind of set up a bunch of drones. You can imagine having a multi-vehicle cooperative fleet doing something really cool. And we're not quite there yet, but we have the whole arc of autonomy in front of us. And I think the long-term vision for Skydio and the whole industry is to have drones as a service, where, as roboticists, we like to tinker with hardware and to have these vehicles that we need to charge up and flash software to and fly and worry about crashing and everything like that. But most people just want something useful done. So imagine just being able to have an insurance company says that you need to have your roof inspected, and they just send out a vehicle to scan your roof and take pictures of it and then annotate it and give you a report and say, yep, your roof still is good and your insurance is valid. Or a police department gets an emergency call and they want to dispatch a drone as first responder to be on site, giving situational awareness and communications with people there before they can get there, maybe even like a half hour before a car can drive out there. And that's actually beginning to happen right now. So Skydio is 10 years old, and we've been through this whole pivot from consumer to enterprise, and as well as public safety and federal. And we've kind of launched what we're calling our Autonomy V3, which is a hardware platform, which is the next generation vehicle that kind of catches up to the best hardware in the industry with a 10x improvement in sensors and compute and all these other cool things. I'm going to drill down to the spatial AI part, because that's the part I work on. I work on a sort of like the mapping and localization component of that. But I just want to tell you a little about the X10. You can go on YouTube and look up some really cool videos that came out. We just launched this about a month ago. We've only launched 3 vehicles in the history of the company. This is a big deal for us. And I mentioned before that before we kind of stood out because of our autonomy, I think now we kind of are competitive with anybody on hardware and still have the best autonomy. This has, you know, the latest NVIDIA Orin compute set, as well as the Qualcomm Snapdragon. And this just really, it's like you have a supercomputer that's flying around, and you can run pretty powerful deep learning models on it. Whereas before you could, but it was more of a trade-off. And I think now it's becoming, it's really amazing what can be done. Yes.
TOPS is math operations? Is that an 85 TOPS? Is that an acronym for floating point operations or something, like trillions of something?
I think so, yes.
Okay.
Yes.
Okay. And then I was gonna ask you, how does that compare to like, will you like get the frame of reference for that? Like what's a regular laptop or something? I don't know, maybe you don't know that.
Yeah, I wish I knew that off the top of my head. Our previous version was the NVIDIA Jetson,
Okay.
which you might be familiar with and I think this is like 10x, it's like a big level up in terms of the number of cores. But I think probably the biggest difference would be to compare the Jetson and the Orin.
Okay.
And then the other thing is our cameras. Skydio has always been built from the ground up to do pure vision-based navigation. We've never had LiDAR on our vehicle. Nothing against LiDAR, but they're expensive and heavy. So if you can manage to do this with off-the-shelf camera hardware, like that is not, and these also are not like super high-end in terms of like global shutter cameras. We have to do a correction for the sort of variable capture of the images, but the resolution of the images has gotten much better now. So here are these like sort of, we have these fisheye cameras that are surrounding the vehicle that provide like a full 360 view for our obstacle avoidance and navigation. And here you can just see a massive difference from our previous enterprise drone and our current one. And you know the resolution of that clock being taken from the same distance.
Yeah, very different.
You know, it's also a modular vehicle that can swap in different components like, you know, thermal sensors, light, infrared, even a parachute that can be, a parachute that can be used if your vehicle needs to operate in a place where you can guarantee it won't ever crash, even in the worst case scenario with a, but I want to drill in on some of the cool things happening in what we kind of put in a bucket of spatial AI. So 3D scan is a sort of that first enterprise skill that I mentioned that launched a couple years ago and was actually what caught my eye and convinced me to jump from autonomous vehicles to autonomous cars to autonomous drones. I saw the VP of Autonomy, Heike Martirios, give a talk at the MIT robotics meetup about this, and it was just like, that's the coolest thing I've ever seen a robot do in the industry. What you can do is the workflow is you basically go on site and the controller gives you like an AR view of these pillars that you can place around the vehicle. And once you fly around, and it takes about, you know, depending on the volume, maybe 5 or 10 minutes to give a rough like polygon prism volume of the area you want to scan, it will then automatically kind of do a rough map of that region and then plan a trajectory to capture high quality photos of every surface of that with perfect overlap so that you can feed it into a 3D reconstruction package and get a really high quality reconstruction. Has anyone here worked with a 3D reconstruction software before, like CalMap or any sort of series solver? Or one of the hardest parts of that is getting good photos. I think it's a challenging problem, but if you have really good photos that capture every surface and have overlap, so you can get correspondences between the two cameras, it's a kind of traditional computer vision techniques for doing 3D reconstruction to work really well. But it's often really hard to capture that. So we automate one of the really hard parts of like before people would be flying around manually taking photos and hope they can get a good volume. Another cool thing we do is now with the X10, it's a powerful enough computer that we can build our own 3D model on the vehicle. The vehicle has a web server on it and you can connect with it even if you're completely off the grid and see on the controller like a full 3D model or orthographic 2D model of the environment you just mapped. And then you can get confidence that yes, you know, we drove out here and spent all this time getting this capture. Is it really the capture we need? And we're not going to drive back and realize that we missed a photo. Now we have automated things that ideally it should be satisfactory no matter what, but people really like being able to see this. Let's see here, what's next? So the visual positioning system is what I work on at Skydio. Now, this is if you've heard the term SLAM before, simultaneous localization and mapping, this is kind of the mapping component of that lets you, we're working on helping you correct for pose drift while you're flying in the same flight, but you can also save that map so that you can use it thereafter to have a more precise trajectory in future flights. Here is just one cool thing that this unlocks is if you have a mission that's going to take to get a picture of the same thing at different times of day. If you don't have a map to help correct for pose drift and you're just working with the odometry system, you can think of an odometry system of being really good and smooth over short distances, but over time it drifts. Imagine walking around with your eyes closed and just imagine kind of estimating where you are based on the steps you've took. Like, I think I'm right here, but eventually it's going to drift. Whereas when you open your eyes, you can look at landmarks and get a sense of where you are in the world. That's kind of what a visual mapping system, how it works. So this lets you, even if this was like, a couple hundred yards away from the takeoff point, getting to this over and over again. On top of sort of working in conjunction with the maps that we build is this thing called the global map, which is kind of another graph that is in reference to this visual map that lets us kind of keep track of where we've flown before and then make reason about what regions are safe to fly. So let's say you do a mapping flight and you fly in a big circle to get coverage. And then later on, you want to plan a mission where it goes out somewhere in the middle and comes back. The global graph will help you understand how to get back most efficiently without necessarily just following the exact same trajectory that you originally took. These are some pretty heavy GIFs we got here. Okay, another thing that it really helps is just planning a repeatable mission through confined spaces. I mean, the obstacle avoidance will help you fly with confidence through a confined space. But if you didn't have a map, you might not be able to get there to that same spot through that corridor. And as importantly, get back to where you took off from to land safely.
You can like fly through hallways.
Yeah, you can fly through a doorway.
Wow.
And I think without a really good obstacle avoidance system, you wouldn't want to be flying a drone through a vehicle, through a doorway. I wish I could do a demo of the in person with the vehicle here to show you that. Here's another example of going through a complex environment in a warehouse. I think the next one is this site maps. And this is kind of building on top of the map that we build for navigation can also be built to reconstruct like a 3D map that is then textured and built up so you can get a sense of the environment that you mapped out that you want to plan missions on. And then we have this 3D model that you can load into like a 3D interface that includes waypoints of missions you want to plan and everything like that. So after the fact, you really have a sense of like what your environment is like when you want to plan missions. Yes.
Does it have, so LiDAR, does it have depth sensing? Or do you get all this information from
It's all from
IMU in a camera?
Yeah, I mean, it's multiple cameras. You have stereo.
Mm-hmm.
That's basically how it's, and then deep range and VIO. Yes.
So these multiple cameras do work like those traditional rangefinders. So like if they find a pixel and then they triangulate the point, this distance based on like the angle.
Yeah, good old triangulation and point-to-point correspondences. If you give me two images and you tell me the point correspondences, we can do a lot with that. So, and a lot of our deep learning models, probably our most important deep learning models are optical flow, which is the same thing as doing deep range between stereo images, which is finding the correspondences between two images. And you can, that's one of the things that deep learning has really unlocked, doing that in noisy environments. Yes?
And all of that, is all that run on the drone hardware to all of these?
So the obstacle map is all done on vehicle, and that map that happens during 3D scan to get a rough sense of where you are. This sort of,
Yeah, the higher level.
this higher level like 3D reconstruction we do offline in the cloud afterwards to help provide context. But so here's a really cool thing that we can do. Once you have a 3D map of an environment, this is a thing that we haven't launched yet. Lets you fly a vehicle over teleop with like a third person mapping view. So it's almost like you can like click on the map and say, go over there, and then we'll fly over there. It's like you're playing a video game, but it's real life. And the entire time you're doing this, there's sort of like this, I guess, like nervous system of the vehicle that has obstacle avoidance. So you're not going to worry about crashing into things. So another cool thing that you can do once you have a site set up that's mapped out is you can import a set of 3D structures from, so let's say you work at a warehouse and you mapped it out, but you already have like a CAD model of all the different shelves and racks. You can import this and then basically say, instead of having to manually fly around or click and set waypoints around your map, which could be very tedious, you can just programmatically say, plan a trajectory that will get a picture of all these different things. And eventually this will show that. The other thing that we can do is, once you know where the structures are in 3D space, and thanks to our visual positioning system, capture a photo during flight of a waypoint, you know pretty precisely where that photo was taken from. And you know in 3D space where that environment, where the structures are. So you can reason about that and then kind of project those 3D structures into the image and annotate them to know which structures are inside of each picture. And then conversely, you can go back and then say, for this structure, give me all the photos that were taken of it, and then feed that into other cool stuff like, OCR, inventory management. So here's an example of our site mission editor. And this is all like a 3D web-based interface where you have this 3D textured mesh. It's a 3D tile set, so it can be loaded at different resolutions dynamically and actually render at scale on a web browser. And you have these crustums that represent the waypoint. And then maybe you have the trajectory that was automatically generated for you. Then you can load it up and make some tweaks and say, actually, it looks like I didn't get that one quite right. I'm going to rotate these waypoints on. And then you could schedule the mission and say, now every morning or once a week, go and help automate the inventory of all of our shelves. And believe it or not, there's some big box stores that one of their biggest problems is they don't know what they have. Like it's really expensive to have someone go around and climb up shelves and keep doing things.
Can I ask you a quick question
Yeah.
about that one?
Yeah.
You could be like, so those are, like that's the path and you're adjusting like the pictures that it's taking, and are the waypoints in there? Are waypoints in the image or no? I just gotta get a feel for like what we're looking at.
So this is, the waypoints are, this is like a 3D editor that lets you kind of set the mission that you want to run.
Okay.
So this is like a 3D editor that shows you a visualization of the waypoints.
Okay, so the waypoints are in there.
Yeah.
Okay.
Yep.
Cool. They're like amazing.
And then here's the structures thing, where like here you can see that on the left here, these structures that are projected into the 3D model, and then into a real photo that was taken. And you can even reason about occlusion. I think we reused one of our ray casting based simulated renderers to render the structures into the cameras and take into account occlusions and things like that to give you a sense of the annotations without taking into account occlusions. And then you can do things like only annotate the ones where, like this one on the right here was a tiny sliver of that structure. You probably don't want to count that as like a valuable photo of that shelf back there. You can kind of get you the best photos that you take of these shelves. All right, so now let's do a hopefully live demo here.
What?
If I can get over to, let's see if I
So
can.
brave.
Okay, so here is one of our testing sites in California, in the East Bay. And I'm going to go over to I'm gonna plan a mission using this. I'm gonna go do a live mission. I'm not sure if I can make this more legible some way, maybe that might help. I should probably make this full screen as well. I think I actually clicked the wrong button. I think I was about to plan a GPS mission here at Michigan, but that could be cool, but I want to create a live mission at one of these sites. So I'm gonna plan a mission by flying the vehicle. So here we go. I'm choosing the vehicle. I'm gonna use Midway 82. Open the live mission planner. Let's call this UM demo.
Is this,
And this is actually live. So here's a camera from the dock, and you can see this drone coming out of it. Ready to go here. And you can say whether you want it to be a GPS or a vision-based one, since indoors, vision-based makes more sense. I'm gonna launch it. Fingers crossed. All right. So when it first launches, it does a little 360 to get oriented. And now I'm controlling it like a kind of a laggy video game here. So I can turn right, turn left. And now, the controls aren't the best, but because this is running the obstacle avoidance, I'm not too worried if I like fat finger the W key, I'm gonna run into a wall. And we also have some nice things like if I want to double click on this thing right here, let's get a picture of that clock. It can reason about where that is in 3D space, then go over and get close to it. That makes it a lot easier to control things too. So just to prove that, yes.
So I saw a fan over there. What if you were to drive like in front of it and were to push the drone out of the way? How would it react to that?
I think it can handle that. I mean, I work on the perception side, not the control side, but we have some tests that they've done where they have like a little wind tunnel and basically stay steady and like land in the dock even if there's like 10-mile-an-hour wind going against you. So I'm gonna add a waypoint here and save it. And now you can see that you get this AR view. So even as I back away, you get a sense of where that photo is gonna be. And let me see, where's that fan? Is it on?
Yeah.
All right, let's check it out. Right, now you know it's a live demo, right? Let's go down, wait, what's the down one? Is it shipped? Yep, shipped. All right, so it's not being blown away here. I think it's moving to the right because it's avoiding that other fan in front of it. So let's get a photo of this. I'll add another waypoint here. Save it. And now so I don't press my luck too much, I'm gonna finish the mission and return to the dock here. And now, this is where it just autonomously goes back, opens the dock. I can get a live view here of the vehicle landing.
is the issue for you guys or no?
Yeah, there is a little bit of latency. It's sort of just like even the same way you might have in just like a Twitch live stream or something like
Yeah.
that. We're using, some of the same technology that's used for live streaming. But again, I think without the obstacle avoidance, you would not want to be doing this.
Okay.
So, and in fact, you can lose connectivity. So let's say that the Wi-Fi goes down while it's in flight. The vehicle has sort of this, it kind of retreats back to its own sense of the world. And if it doesn't hear from the connection within a certain timeout, it will just go and land automatically. And a little secret here, that happened when I was trying to demo, when I was practicing earlier. And so that actually would be kind of a cool demo because we have this testing site where we have all these vehicles automatically flying all the time. And recently we've been adding a bunch more, and that we have all these drones in the same Wi-Fi network. So it's kind of like a networking issue that can happen, but. Okay.
So we have a question from someone online. They were asking, can the drone follow moving objects such as a person walking around?
Yeah, that was one of the first things that we got working with the consumer line, where you could, when I first joined, I got to have one of these consumer drones, and I got a video of like, it's going in reverse because it has these 360 cameras and it's flying in reverse with the subject camera on me while I'm bicycling. So I have this cool video of, lame me and a mountain bike in a suburban neighborhood, but still I felt cool doing it. All right, so now this is done. I'm gonna go back to the view here and I'm gonna go exit. And you can see that now it's uploading the map it created and stuff like that. So let's come back later and I'll have a second demo where we try to execute that mission I just planned. Because right now that map is being uploaded to the cloud where it's going to be optimized, and which is basically this pose graph optimization procedure. If you ever come across those terms in your robotics courses, optimizing the pose graph, running offline SLAM, and then it will be ready to send to any vehicle that we want to run that mission. So let me go back and presentation here and shift gears to talk about my path coming here. So I originally graduated from Michigan. Here's me with my proud parents. And my first job out of the master's program was working at Google. I started working on the AdWords product, the API, where people would programmatically schedule their ad campaigns and manage bids and things like that. And after a couple of years on that, I switched over to the Android project. And that was before the very first device even launched. So it seemed like a kind of an internal cool project that we didn't know it was going to go anywhere. So it was both very cool I happened to be there and also reveals how old I am, that I was working on this project before smartphones were a thing, basically. And after that, and one thing I want to say just about how Michigan prepared me for those two experiences, those are quite different projects. It was like almost like two different, completely different teams working completely different things. And I think some of the fundamentals that I learned just about like not only how to write software, but how does software execute on a machine? How do computers work? How do operating systems work? How do networking work? It kind of made me feel comfortable, starting on these different projects without prior experience on those things and coming up to speed. So I hope you all feel similarly as you enter your first jobs. So I was working out in California and I wanted to move back to Ann Arbor, and I also wanted to start a company. So I did both and moved back here and started this company, this kind of crazy idealistic idea called realtimefarms.com. And the idea was to help people see where their food comes from. Very Portlandia for the times, but the idea was to improve food transparency so that no matter what you think about how food should be grown, you can at least find out about it. And our customers were restaurants that could trace every ingredient on their menu back to the farm it came from, and you could be on this interactive map and see the connections to the food web. And we had like 100 restaurants signed up, and we got started in Ann Arbor, so that was really fun. Here's me with one of the first chefs in New York that signed up for it. And then eventually we were acquired by a food media company in New York called Food 52. And fast forward a couple of years, I found myself managing a team of designers and engineers as we launched like this commerce system integrated with their content management system. And that was actually a very challenging software engineering project and really fun. But I also found that like at the same time, this is about 2016, or maybe a little earlier, there was this machine learning revolution. Like every week it felt like something big was happening. Like suddenly computers could classify images, and like they couldn't do that before. It just never was very good at that. ImageNet and segmentation. So I just felt like I wanted to dig my fingers back into the dirt and get more technical. So I took about 6 months off, quit my job, and was studying at home, just like studying these online machine learning courses. This was like when Coursera first came out, like Andrew Ng's course, and brushing up on the statistics and linear algebra I'd taken at Michigan. And then that led to a job at Michigan Robotics. This was before this building existed, actually. But not that surprising because this building is brand new, but I joined the FCAD lab working with Matt and Ram. I know Matt's at CMU now, but perhaps you recognize some of these faces. And that was just a great experience because I didn't know that much about robotics, but I knew some of the fundamentals that helped with robotics and could help write software to do some of the tooling we needed for research. So one of the first projects we worked on was this project called Driving in the Matrix, where we harvested ground truth data from Grand Theft Auto there's like this guy, Charles Bartow, this kind of graphics and video game whiz, and he kind of wrote a plugin for Grand Theft Auto that would intercept like the stencil buffer where you could get the depth of everything in the scene, and from that we could back out what the sort of class, what the object class of every pixel in the image was, and then we harvested ground truth data from that and used it to train at the time some of the best machine learning models like faster RCNN and things like that to see if could you train these networks on synthetic data and have it get better on real world scenes like the cities companies. And it could, and it turned out the more data you gave it, we started with 50,000 and 100,000, then we actually got to 1 million images that we harvested from this. And so my job was to take all this data and run it through all these different networks and build Docker containers so we could wrangle 5 different networks. And we had like a NFS-based job queue running on the machines in the lab. And so it was like, that's where my software engineering skills came to bear, where I could be useful in that way. But along the way, I was learning a lot about this technology. The other project was a data set where we captured yes.
You guys still do anything like that with virtual, like scenes, generating them, and then using that to train current models or anything, or are you using mostly like real world stuff?
At Skydio? Yeah, it's a lot of synthetic data because the kinds of things that we want to, that are challenging for us, like thin wires and thin branches and just different variations, like, at the time, Grand Theft Auto was like better than a lot of the sort of open source robotic simulators, but now all that stuff's caught up and we actually have a team working full time on generating synthetic data, and someone who actually used to work in the Ford Robotics team. What's her name? I'm looking at her name, but anyway, like they're very big for the data we use to train our models. Another data set was we brought one of the Ford vehicles out and put a new sensor rig on it that had 2 sets of stereo pairs synchronized with the LiDAR. So we would capture images from both stereo pairs and then kind of clean it up and get a bunch of keyframes that had both stereo pairs, a point cloud. And then we had all that data annotated by a third party firm. And then for every sort of pedestrian that we found in the scene, we ran like an optimization procedure to triangulate and figure out what the skeleton joints were of every one, and also like infer what a shape model was of each person. So then we had a nice ground truth data set of just stereo imagery for pedestrians. And that was a great experience because it was just like bread and butter robotics, collecting data, getting cameras calibrated, knowing where they are with respect to each other, calibrating the intrinsics. That's where those checkerboards are. Has anyone ever had to calibrate a camera before for robotics? OpenCV checkerboard. Hopefully you'll get to do that sometime. It's very cool. And then that eventually led to getting a job at Toyota Research Institute, working on their autonomous vehicle and Guardian project. And there I worked on some of the mapping software where you have the idea that you have a system that can build a map of one environment, but you want to build a map of potentially the entire world for their network. So if you want to use this on all Toyota vehicles eventually, you want to have a map of potentially world scale. So I was thinking about how do we break this problem down and do it in a distributed way. So we basically broke the world into tiles, broke it into sub-problems, optimized them concurrently, and then had to find a way to kind of smooth over between the different maps and have it all be consistent. So that was a really fascinating project. And then that brought me to Skydio. So that brings me full circle to this demo where with any luck, that map that we just built is ready. All right. So now let's run this mission. And we'll run it on the same one that we did. So we need to initiate a download of this map back to the vehicle. And as soon as it's ready, it will launch into the telop view where we can tell it to go ahead. So while we're waiting for this, typically it's faster than this. I'm not sure what's going on. The last slide of this talk that I was going to do after I show you executing this mission was basically just like some lessons about that I've learned in my career. So I'll just start talking about that while we watch this download. And if it does not download, then I'll at least chalk it up to a half of a decent demo. So the first lesson I have here is to not be afraid to ask for what you want, but also after you've proven your value. I think there's been a couple examples of that. One was when I first joined Google, I was really excited about distributed systems. This was back when like MapReduce was, they had a paper on MapReduce and Bigtable and obviously search infrastructure. And I got assigned to the AdWords API, which was not something I was familiar with. And I was like, what is this, But you're not going to be one to raise a fuss on your first day at a new job, right? So I think I just found that like it was still a really fascinating technical problem. The people I was working with were really smart, and I found that if I just did my best to be a contribution, eventually I got to a point where I had the kind of career capital to ask to work on something else that I also found interesting. So eventually, after a couple of years at Google, I looked around at all the different cool internal projects. At that point, like Google Chrome was launching and Android was an internal project. Those were a couple I was thinking about. And I was able to move on to that. More recently, even working at Skydio, I think, and this also ties, this kind of combines with my next point, is that as you work in industry for a while, even if you change your focus, your past experience is often valuable in unexpected ways. When I first joined Skydio, one of the first things that they were trying to get working was this kind of offline map optimization pipeline. And I kind of led that project, and now it's ready. So while I was giving the rest of the talk and it was optimizing the cloud, that process of like thinking through how do you manage the data lifecycle of some robotic map as it makes its way from the vehicle to the cloud back to the vehicle, that's not like pure robotic work. You're not working on like computer vision or machine learning or state estimation, but it's still extremely important to the product. So having the domain knowledge about mapping, but having the past experience working on like full stack web stuff and distributed systems like came in really handy. And I worked on that for about a year. And in the meantime, I've been on the team of all the people from the PhDs and experts doing computer vision, and I've found myself able to work more directly on some of the core state estimation problems. So again, I found that just be patient, make a contribution, but then keep asking for what you want. And I think I found that it works out pretty well. So here we go. I'm going to launch this. And if you remember, we just had 2 waypoints. So after it orients itself, a picture of that clock. And let's go back. Oh yeah, so the other thing I was going to talk about while this lands here, fingers crossed the last part does not go awry. All right, One thing I want to point out, let's see if it does it. After it lands, when it's coming back in. So you see how it kind of goes back out and back in. Anyone has a guess of why we do that?
Like just taking multiple pictures, recalibrating several times, or you just, oh, you're trying to make sure it doesn't fall off?
Well, it's close. We're trying to make sure it kind of gets, nuzzles back in and gets connected so the battery connects to the charger, the sort of charging leads. I think before when we just pulled it back in, sometimes it'd be just a little bit off, and then it wouldn't be charging, and you have to call the there's a phone number you can call that warehouse where some security guard will come and help put it back in place. But now, after we have all these metrics about what percentage of landings are completely autonomous, and that's keeps on going up, and those little adjustments are the things that help. All right, cool. So that concludes the live demo. And then, eventually you can go and look at your mission executions, and you can see the photos of the things that you took. I could show you that, but I just want to get back to the presentation and kind of wrap up here. The last point I wanted to make is that, one is that you should always be learning. I mean, I think that as students, you're experienced with what it takes to learn something the first time, but I think that's just the beginning. I mean, things change so fast. Like the world today, since when I graduated, in some ways there are some fundamentals that are very relevant, but there's just a bunch of new things that have happened, obviously. And if you kind of have this mindset of like, this is exciting, I want to keep learning and figuring out what's most relevant, that'll suit you really well. And one tip in particular, this tool that I started using, not until I took that summer off. Has anyone ever used like a flashcard software called Anki, A-N-K-I before? Anyone heard of that? All right, Google that, A-N-K-I. It's spaced repetition flashcard software. And what it does is you can create a flashcard for yourself, like, what is a quaternion or whatever it might be that you're learning about robotics. And then it will challenge you on a schedule where like maybe you spend 10 minutes a day reviewing your flashcards. And it will kind of do an exponential back off. So like the first couple of days it'll challenge you and you keep on forgetting, and then it sticks, checks back a week later, then a month later, then a year later. And because of that exponential back off, you essentially can maintain knowledge of an unbounded amount of things with a fixed amount of time every day. So as I've continued to learn over the time, I keep on adding stuff to my deck. And eventually you might come back and realize, what, I don't care about that anymore, and you can remove it, you can print it out. But I found, I'm not someone who retains things automatically. Maybe you have some friends who like remember everything from their linear algebra course. Like I had forgotten everything, so I had to go back and learn it. And this time, I would just say that if you're taking a class and you feel like this is really useful and I want to remember it, think about not only learning it the first time, but designing a system that helps you remember it for as long as you'd like to retain it. And the final tip I want to give is that if you find yourself in industry, you have a job, and you're coming out from a student budget and you're making some good money for the first time in your life, maybe don't level up your lifestyle to match your new job right away. Save some money, because one of the most useful things, and again, this was certainly a privilege, not everybody could do this, but if you're able to, you can't, taking 6 months off of work obviously is not something you can do without some savings. And if I hadn't been able to do that, and also be able to take a pay cut temporarily as I entered a new industry, if you kind of get locked into the maximum lifestyle that your job affords, you might not have the flexibility to do something like I did and decide that I want to do something different. Like probably not. I think robotics is it for me, but maybe in a few years I want to do biomedical engineering or something like that, or who knows. But I think I would just highly recommend that if you find yourself with the ability to give yourself a cushion so that you have the flexibility to learn in a deeper way or transition, that you're able to do that. That's it. Thank you.